everyone, my name is Bella and this is my module reflection on graph traversals. So many of the algorithms that we've covered so far have been directly tied to clear real-world problems. For example, the greedy algorithm solved the knapsack problem in our Princess Quest, and the propose and reject algorithm solved our stable matching problem. In both cases, we started with a concrete real-world scenario, and the algorithm provided us with a solution. But not all algorithms are designed that way. Some are designed to solve problems that feel a bit more abstract, where the connection to real life isn't immediately obvious. I would put this week's topic into that category. This week we covered two algorithms for traversing graphs: breadth first search, or BFS, and depth first search, or DFS. The first traversal algorithm, BFS, explores a graph layer by layer. It starts from a single node and visits all of its immediate neighbors before moving on to the next layer. You can imagine it like throwing a stone into a pond. The ripples move outward in waves from the landing place of the stone, and in the same way, BFS systematically explores everything that's one step away, and then 2 steps away, and so on. DFS, on the other hand, takes a different approach. Instead of exploring broadly, it dives deep. You follow one path as far as it goes, and when you hit a dead end, you backtrack and you try another path. It's a bit like navigating a maze. You follow one hallway until it stops, and then you retrace your steps to find a new route. At their core, these algorithms are systematic ways in which you can move through a graph. Mathematically, a graph is just a set of vertices connected by edges, which might sound simple or even a little dry, but that abstraction is actually what makes graphs so powerful. They can represent almost anything that involves relationships or connections. Graphs can model social networks, road systems, or even sequences of random events. And because graphs themselves are everywhere, these traversal techniques are remarkably versatile. One especially fascinating application is in web crawling. This is the process through which search engines send out bots called spiders or crawlers, and these bots discover and index pages across the internet. If we think of the web as one giant directed graph, with each web page being a node and every hyperlink being an edge, a web crawler uses traversal algorithms to systematically visit pages, record the information on those pages, and then find new links to follow. Oftentimes, it uses a variation of breadth first search, and this makes sense. BFS lets the crawler visit spaces in order of their distance from the starting page, quickly expanding coverage while maintaining a sense of relevance to that starting page. DFS, in contrast, might be used for more specialized searches, like when you want to go deep down into a specific topic, or as we might say, go down a rabbit hole. This is just one example of how an abstract algorithmic concept like graph traversals has enormous practical impact. What I really enjoy learning about BFS and DFS is how they blend theory with intuition. They might seem complicated at first, but they're not just computational procedures. They also mirror the way that we as humans explore ideas. Sometimes we might want to think broadly, weighing a whole subset of our options at a time, like BFS. Other times we might want to go deeper into one possibility and then backtrack to find a new solution, kind of like DFS. So thank you all for listening to my topic reflection on graph traversals.